Hello everyone and welcome back to a new video for our math project. And today we are going to do something new which is related to calculus, and it's called related rates. You see how I did that? Rates, related. Sorry. Yeah, no, it's fine. So what we are going to do this time is something related to related rates, like I said. So let's get into it. I hope you can see the screen. And this is a question that I have formed. A water tank has this shape of an inverted right circular cone with its axis vertical and vertex lowermost. Its semi-vertical angle is 0.25, sorry, tangent of 0.5, not 2, 0.25. Tangent inverse of 0.5. Water is poured into it at a constant rate of 5 cubic meters per hour, and we have to find the rate at which the level of the water is rising at the instant when the depth of water in the tank is 4 meters. Now, to assist you with this kind of problem, it's a bunch of words, I know, right? It's I've made that type of question intentionally so that it's going to confuse you, but we have a bunch of things in there that's that should be popping right onto our eyes. So to assist you, I have got here a figure, and that would seriously help you. Now, this is what how the whole cone would look like. The water tank would look like. So you have the cone right here. Now, if you go back to the question said it's a water tank with a shape inverted right circular cone. Right circular cone simply means it has a the central angle from the base. So yeah, the center is 90 degrees and it's inverted. It's flipped rather than the normal cone that's going to be something like this. So it's going to be inverted and it's going to be something like that. Now, and what it said, the vertex lowermost, it simply means it's inverted. So the vertex is going to be right here. If you can see my mouse, one second, I think you can. Um, if you can see my mouse, it's somewhere right here. That's the vertex at the lowermost. So that's what it means. And then the next thing that the question said, it's semi-vertical angle. That's a really important thing to note, that the semi-vertical angle is simply this point right here, which is alpha. You see there. Oh boy, what am I doing? You see this right here. This is alpha, and that's the semi-vertical angle. So what it means is the angle that's adjacent to the right angle but perpendicular to the base radius. That's what it all means with the semi-vertical angle. And we have the value as tan inverse of 0.5. It's not a complete degree or radian angle value. And honestly speaking, we don't even need that. So, and we also know one thing that it's going to be poured, the water is going to be poured at a rate of 5 cubic meters per hour. And we just have to find the rate at which the water level is going to rise at the instant when the tank has depth of 4 meters. So let's get started with the problem solving. If you did this question and you got the answer correct, I guess, you can just check out how I got the answer. And if you did not get it correct, well, this is the time to understand and learn more about how the things work in calculus and related rates, which is related to calculus. All right. So I'm going to share a new screen. And once I pull up the new screen, all right, I I started a new screen right here. It's a journal thing. So there we have our figure right here. And now we start on the answers. We have this figure to assist and mainly to understand it, right? What we know, I have just discussed all of that with you guys. And yeah, the real steps now start. Now, what we know is that alpha equals to the tangent inverse of radius over height. So tangent is simply opposite over adjacent, right? So Katua, if you remember, so opposite side is directly proportional and the adjacent side is inversely proportional. So that's what it simply means after you get that. So alpha equals, I made a mistake right here. It's not 0.25. Alpha equals tangent inverse of 0.5. We are already given that, right? So we can just replace it, right? So we should not replace it. So what I've done here is I multiplied this right here with tangent of alpha on both sides of the equation, on the left hand side and right hand side. And then you get this right here, the following, which is tangent of alpha equals to 0.5. So by that, I got rid of tangent inverse, tan inverse, the tan negative one thing that I had. So I got rid of that. And then now I have a very simply formulated equation right here. Tangent of alpha equals 0.5. Now, we know that tangent is also equal to radius over the height from the figure that we had, right? So if I go back to the figure, this is my angle. Opposite is this, which is R, and then adjacent is H. So we can just replace that right into this equation, and then we finally get radius over height equals 0.5. And then we can just solve it for radius for R, which is then going to be R equals 0.5 H or R equals H over 2 in the fractional form. It's just for to make it simple. And then we have noted it down as number 2, the second equation that we are going to use later on in the future. Now, step 4. We know that volume of a cone can be identified with this equation, which is V equals 1 over 3 pi r squared h. And we are going to use this equation. Now, what we have to do is we are going to find the derivative so that we can find the rate of change of water level at the depth of 4 meters. So we find the derivative, but before we get into that, we need to substitute the equation number 2 that we had right here, R equals H over 2, into this equation, in the volume equation, right? Then we replace that equation in there, and then it's going to be 1 over 3 pi H over 2 whole squared times H, right? So I replaced R with this, right? So it's going to later on give us 1 over 3 pi H cubed all over 4. Uh, you can just multiply things out to make it simple, which is going to be pi H cubed all over 12. And this is the fourth equation that we would use in the future. Now we find the derivative, and we're going to find the derivative for number fourth, the fourth equation. So to find the derivative, it's very simple. You find the we are going to get dv over dt on the left side, and on the right side, after we walk through the power rule, we are going to get this right here, pi h squared over 4 times dh over dt. All right. Now we know a bunch of values right now only. dv over dt, we know what that is. We know that it's 5 cubic meters over an hour. and we know what the height is, which is h, so which is 4. So we can just substitute it all inside the number fifth equation right here, and then we substitute everything, and then later on we get dh over dt, that's equal to something like this, 4 meters per 4 pi per hour. But we don't want in 4 pi r, right? Because it's not really how we work through things. So what we are going to get is 0.39788 meters per hour. Or you can just round it out to 3 decimal places, 0.398 meters per hour. Or in fractional form, it's going to be 9947 all over 25,000 meters per hour. Or you can just say any fraction that's equivalent to it if we just add something else. So yes, that's how you complete a question right there. And to the question that I had given in there. And if you got the question correct, the answer correct, great job. It was, I think it was a really difficult question to answer, I'll say. And if you did not got it correct and you now understand it, that's really great. You can ask me any questions if you want in the chat box area. And then, yeah, that's it. If you like the video, please like it, share it if you want to, and subscribe to the channel if you would like to. And ask me any questions if you have in the chat box. Thank you so much. You have a good one. See ya and boom.